Welcome everyone. So my name is Mihir Gulabai and I am the Advanced MES Team Specialist at Epicor Advanced. Today we'll be looking at Advanced MES. In terms of an agenda, what we'll be covering is we're looking at what Advanced MES is. We look at the various capabilities of the Advanced MES software. We're looking at the key benefits which the Advanced MES software is able to give you. We'll be looking at then the why and the how. And then finally, I'll be taking you through a demonstration of the various dashboards and information which you'll have all at your fingertips within the software itself. To touch on what is Advanced MES. So MES is a manufacturing execution system which allows you to monitor systems on a factory floor, and it's not directly restricted to a factory floor. It could be across different industries such as from farming, looking at greenhouses, etc. So the main goal of an Advanced MES software is obviously to ensure effective execution, and in terms of better monitoring, and the key point which I touched on already is just having all that information at your fingertips. So if we quickly look at the architecture of Advanced MES, we can either have machinery, be it actual physical machines like an injection molding machine. It could even be sensors such as temperature sensors, humidity sensors, etc. And all of that information is connected to, we can either have it to a physical MIU, which is actually a machine interface unit. So that helps with direct links or direct coded links between your actual MIU device and the actual machinery itself. The other option is an OPC route, which can be seen as a wireless route, which minimizes the need of having actual direct links. And that OPC or MT connect, so that is a bit of a wireless connection, so it minimizes the need for actually having physical wires running through, and is done through the machine's PLC or added PLC for that matter. So now the big question is, we have all this information coming through from various machines and can be through various different sensors, but how does it all visually appear into one spot? That can be done through the actual real-time display, which I'll be covering into more detail later in my demonstration. But that information that you get from a real-time display either talks from a QC point of view, so that's your quality control point of view. It can actually be per department. So if you have an injection molding department or a extrusion department or an assembly department, you can now have that information based on different departments. You even have from a plant manager point of view, where you have a whole production control view of all the machines that are currently active, that are running, and you have a lot of information at your fingertips, such as why this machine is down with the relevant reasons. You're able to gauge what the speeds are running at, or in terms of temperature sensors or pressure sensors, what's the current temperature and what's the current pressure, etc., all on a real-time basis. Not to forget the operators. The operators also have a HMI, which is a human media interface. What the HMI does is it can be in terms of a touchscreen device. So it will help then the operator walk around or have it physically at the machine, and the operator now has the functionality of being able to change jobs. They can report scrap. They're able to report pack production. They can even do, from a QC point of view, take manual samples and capture the attributes which can be just seen as your QC control input, such as what's the temperature of this part, the radius of this part, etc., and have that inputted all in one, and all of this channels through into the main software, and then even from a production control or plant floor viewer or a QC manager for that matter has all that information at their fingertips. So that is it in terms of what is Advanced MES, and then just a brief introduction is what are the capabilities of Advanced MES. Now these actually touch on the key pain points that customers do experience. To start off with, from production monitoring point of view, so the capability of Advanced MES allows you to have a real-time display of production monitoring, all either on a summarized level or at a detailed level. And it doesn't necessarily you have to be at the factory floor. It can be, you can be overseas and have that information in terms of a either by a laptop connecting to your server, and you'll be able to have all that information remotely as well. The common key points, I mean, if we just talk through it quickly, it's just traceability. The next time is also what I touched on, is your real-time display. You don't necessarily know what's currently happening on your production floor, and with the capabilities of Advanced MES, you're now able to better track what's going on your floor and have a much more immediate response to fixing issues as well. The next one is energy monitoring. Now, energy monitoring allows you to have energy monitoring systems or energy monitoring sensors on your machines itself, and you're able to monitor either per machine or per grouped machines as a whole in terms of energy consumption, and it helps you be more energy wise and green as well. The next one is on planning and scheduling. So planning and scheduling in Advanced MES allows you to forward plan and forward schedule all your jobs currently that needs to happen, and you are able to, by means of drag and drop functionality, even easily reschedule certain things. So if we just talk to the pain points of scheduling, the main thing is, because we don't have real traceability in the system, we're not actually sure what is scheduled to be planned next. Or the other key points is that what machine is actually best for the job. So with the software, you're able to see a where to run type of approach, meaning the system will suggest to you, based on the current load of the machine, which machine is capable and which is actually to best run on. The other one talks to, next capability is your quality management. Now, the big thing about quality management is you actually wanting to improve your productivity, and that comes from a big key point, which is actually on scrap. You have too much scrap, you don't have the actual recording of how much scrap you're making, and as well as that's a direct influence on your OEE of a machine, which is just your overall effectiveness of the machine. So with the capabilities, you're now able to, per job and per machine, able to gauge what the scraps you are producing, and that will then speak to either operator related issues, or it could be even jump down to machine related issues, with the main aim of reducing scrap and improving productivity. The next one capability we'll be looking at is visibility of reporting. So yes, you have all this information in terms of your dashboards and various, from an operator point of view in terms of the HMI, but in reporting point of view, there is various reports in Advanced MES, such as your job production report, that you can view either per shift basis or for the entire job itself. And from the single report, you're able to gauge where you currently are at with the job, what are the main downtime reasons, and what is it grouped under, be it either there was no material on the machine, or there's an issue with the mold, or an issue with the part being produced. You'll even have a global view of the scrap. So again, this is just bringing all the information together, and that touches on all the different capabilities. So from production, you're able to have a report. From a quality management point of view, and as well, you'll be able to have a report. And the next, or the final capability I do want to talk to, and a very important one, is actually alerts and notifications. So you aren't necessarily not at your desk all the time, or not actually viewing the dashboard at the time, or even for an operator, you're not physically sitting at the machine 24/7, but you do want to be notified in terms of when an alert actually gets triggered, or when do you want a notification get sent through. There is a workflow, therefore, in Advanced MES that allows you to determine based on certain things, such that if your machine is running too fast, or if the product output is too slow, or in terms of temperatures, or whatever you want to monitor is not within the limits you deem as normal, you're able to then automatically trigger either a voice alert, or even have an email sent through to the people. So that goes across various different things. You are even able to auto email reports to yourself. So for example, if you want production detail reports to yourself every morning, you are able to do that through the software as well. So now for the interesting part, we will now be demoing the Advanced MES software in terms of either a production or quality control view, and we're looking at various dashboards, such as your real-time display. We're looking at your plant floor display, which gives you an overall view of all the current machines on your plant and the statuses in terms of summaries, as well as color codes, which becomes very efficient and very effective and easy to read. And then we'll be looking at an OEE dashboard, where you are able to as well set OEE targets for a different department to reach, or in terms of the factory as a whole to breathe. So yes, hope you enjoy the demonstration. Thank you.
Welcome to the real-time display of Advanced MES. The real-time display is mainly used by job operation managers along with production managers, and it gives a global overview as well as detailed insight to what's actually occurring on the job floor. The real-time display in front of us contains quite a amount of information, and it can be set up either on a per job based, meaning on a global job based level, or per shift, which is the manner in which we actually set up the demo for today. Just running through the real-time display and what information it actually gives us, starting from left to right, we can start off with the machine number. So the machine number is just essentially what machine you're actually running with, and additionally it is separated per department. So you can see we have departments categorized as the assembly department, we have blow molding department, die casting department, extrusion department, as well as injection department with their machines grouped to the department. Further to that, we have SH, which is just the shift. The shift essentially just tells you what's the current shift of the machines at the moment. So in this case, we're still running along shift 1. The next one is the job number. The job number is specified by the job setup and can either be named in terms of the part, or it can be named in terms of an actual number, and it's all dependent on how the user does want to name the job. The next column we have HP, which is a help call. A help call is essentially what a job floor operator will select from their HMI, which is a tablet driven or touchscreen driven PC tablet, whereby users can then submit a call for help, whereby it can either be for maintenance requirements, and that then further links to a voice and email alert system, which then you'll further be able to identify specific calls for help as well. The other information we do have is goods production. This is currently based on the current counter of the machine as well as the signals that are connected to, either based on cycle times, or if we're running on encoder, which is measuring pulses per minute, which can be converted to meters per minute, or if we're measuring in terms of an assembly department, the amounts of parts assembled per minute, and it's all dependent on the shop application, whereby there is a numerous amount of production standards we can actually measure against. We then have expected parts. Expected parts is an identifier to say that for this given moment in time, based on the setups of the jobs as well as the standard speeds and standard cycles or standard packing times, etc., that at this given point in time you have meant to made X amount of parts within this moment. And this gives you a good gauge to say that, okay, my expected parts is this amount, but I've only currently produced this amount. And from there, you're able to further identify issues such as either the machine's running slower than normal, it's either running faster than normal, and you're able to then look into further details into it. Another thing which we do have is good productions to go. So this is a counter which decreases based on the amount of good production. So this is just a gauge to say that for the job it was set up as 15,000, however good production has been 122, therefore my good production to go is that amount. Further to that, based on your standard setups, it also then translates it to hours to go. So in this instance here, we have 593 hours for this job to complete. Other information we do have is your standard speed, which is actually set up against the machine to say that for this job running on this machine, it's meant to be, if I take an example of extrusion, for this EXT01, and for that job it's creating, for that part it's manufacturing, it's meant to be running at a standard speed of 5 meters per minute, or it can be 5 meters per second. and you further then have a gauge against the actual speed. Now the actual speed is what's actually currently being monitored by the sensors. In this case here, we can see that we do have a match of the actual speed versus the standard speed. There can be cases whereby we are running fairly slower. In this example, we're only running 9.5 other than 10. That all of this information then is what used to actually calculate the yield efficiency. So a quick calculation for the yield efficiency is a percentage of the goods production divided by your expected production. So again, that's where your standard versus actual occurs, and it's also a good gauge to identify any gray areas or any areas which are excelling and any areas which need further improvements upon. Again, the main goal is to always improve quality of productivity as well as the quality itself, and to reduce scrap at the end of the day. Furthermore, we do have standard cavities versus actual cavities. This will apply quite a bit for injection as well, whereby you have a standard cavity of 6, meaning that that mold has 6 cavities. However, in actual sense, you might only be using 5 of those cavities or 4 of those cavities in the actual production floor, because they could potentially have been blocked due to material leakages, etc. So you do get quite a bit of information from that level as well. These standard cavities are either submitted through the HMI, which again the shop floor operator can use, such that they can on the fly submit to say that, okay, I started off running with 6 cavities, however, I'm now down to 4 cavities. So it then constantly updates, and that standard active cavities is what then runs in terms of the good production, because every cycle that's run, it's going to look at the active cavities. So for each cycle, I'm expecting in this case 1 part. However, in that scenario where I was meant to have 6 standard cavities, however I'm only running 4, then I'm only going to be creating 6, or as in supposed to be creating 6, but now I'm only running at 4 parts per cycle. Further information we do get is your down description. Now a down description is essentially when the machine triggers as down. So the machine can be down for various reasons, such as it's in the machine setup mode, or there can be no material, and all of these down statuses are set up and can be variously set up as well, depending on the business case or the business scenario. Before I dive into further details or further functionality of the real-time display, I do want to take your focus to what we know as a plant floor display. A plant floor display is essentially a global view of all the machines that are currently running, and you can see it can be set up based on certain icons and can be displayed as well and on a big screen for the shop floor users, such that they can easily identify based on the color as well the status of the machine. So just to run through the statuses, or in terms of the colors, if it's green, that means the machine is running okay, meaning we're not running over certain limits set up of the machine in terms of the actual speeds which it's running. We then have a red status. Now, a red status essentially means that we are currently running out of spec. So for an example, if I double click on this, we're able to get much more functionality. So you can see here we're currently running out of spec. And from this, the operator will then be able to identify to say that, okay, I'm actually running at 2. However, I mean to be running at a nominal of 30 and between the limits of 24 and 36. So hence it's flagged as out of spec, either below that limit or above that limit. Then we have a color which is as yellow. Now yellow is when the machine is actually in downtime. Again, if I double click, I get much more information into this, as well as telling me what the down status is. Again, this can be categorized to either machine setup or material problem, etc. So this is a good view that can be, as mentioned, set up on a big TV or a screen such that the users or shop floor employees can easily identify the state of the machines, and this can be correlated in terms of voice and email alerts, such that if down is triggered, it can activate a down alert, or if it's running out of spec, it can activate alert as well. You can see, just to go into further more details, coming down to using that method, when I'm able to see the details of this. What details this machine status gives us is what's my machine number, which is notified there, what currently is the job number, which was seen within the real-time display, what the current part is, meaning what am I manufacturing, what tools actually be using for in this case. So that tool could be a mold, it could be a certain blow molding tool in this case as well. Different to that, you have different functionalities such as your overview. So again, your overview is going to tell you total production against the job. It's going to tell you what's the total production for the current shift you're running at, and against all the job as well as the shift. You can see a good production, how much has been scrapped based on what's out of spec or what's manually captured as scrap. If there's any pack production which can get captured, the amount of machine cycles, the setup cycles, non-production cycles, cycles out of spec. So at this moment, you can currently see there has been 12 cycles out of spec. Then you have things such as what my runtime is. So the machine has been running for X amount of hours, um, and of which the downtime was X another amount of hours, as well as you get different down counts, which able to identify you across that period of the runtime, and that total downtime, your downtime has been prevalent for 8 occasions as well. So that's quite a bit of information you do get. Jumping to the machine status, it's going to tell you what the current status of the machine is. It's going to tell you how long it's been running within that status, if there is any help called against it, as well as the efficiency on a job basis and on the yield basis as well. And furthermore, as mentioned, is mainly applied to injection molding cases or blow molding cases where we have the case of the cavities as well. Jumping to the process alarm. A process alarm is just a quick view of what my current cycle time is versus what my nominal is set up, which is basically your standards, and what my lower spec specification limit is and what my upper specification limit is, and that's what controls what's running within spec or out of spec as well. Then there is certain things that can be monitored, such as what my blow time is, my APSI, my injection pressures, my zone 1 temperatures, and quite a variety of different sensing parameters set up against that specific machine. You also do have visibility of material usage. So to say that in standard sense, I'm using 3.8 grams per 1,000 parts, 0.9 of PVC, etc. And based on the current job, so if there has been anything running, you'll be able to see that for the current shift or for the current job, I'm actually running this amount for now. Additionally to that, you do have setup sheets, which is all can be linked, which will just tell you what my tool descriptor is, what part descriptor is, just additional information as well, and what's the next job which can be run on here. So you can have a view of, without even running the job, having a view of, okay, this is the next job to be run, what materials are needed, and all of those different functionalities as well. Jumping down to one of the down descriptions, again you can see the status is marked as down, and additionally if we go to one of the green ones, you're able to see a status as well as running okay. And just as a reminder, we do then have running out of spec. So that's the functionality we do get from a plant flow viewer. Additionally to that, you do have a global dashboard view. So this global dashboard view, which you can see summaries of your overall efficiencies, your yield efficiencies, what your average cycle time has been, if there's any scrap reduction against it, how long has it been down, and you get an infographic in terms of a bar graph to say, okay, this is the actual good parts versus scrap parts. As of current, we aren't running any scrap, as well as you get information such as, okay, for this time I am running my machine for X amount, of which has been down, of which has been idle, meaning the machine hasn't been running. And this dashboard gives you in a digital view as well, in terms of overall across all these departments what the overall efficiency is. As you can see, again, it's real-time display, so depending on all what's happening on the plant floor, it will constantly be increasing or decreasing for that matter. This can be filtered by department. So if I only want to look at my injection department, you can see then it's very specific to that injection department. In this case here, I can already see based on the color coding that machine is down, and it's been down for that amount of time thus far. And I can see further information as well, just from a color coding perspective, which can be set up against limits. And if I just run through the assembly department, you can see it's specific to them. And if I just look at all departments again, you can see all the machines that are currently down and all of these machines. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, and all of that will link to the plant floor to show you all of that there. So that's the information we do get on the OEE dashboard, which is a very good global overview. As you can see, as scrap starts to increase, you do get live changes.
So I really hope you enjoyed that demonstration, and now you'll realize why we rank the #1 leader in MES. To get in touch with me, you're more than welcome to find me on social media platforms and on LinkedIn as well. And please get in touch with us either by email, or you're more than welcome to visit our website. Thank you so much for your time.